Into my YouTube channel. My name is Mario, and today we're going to be talking about the Tribonacci sequence in JavaScript and a couple of ways to solve this. So the Tribonacci sequence is pretty much a variation of Fibonacci. So if you remember, Fibonacci is the sum of the two preceding values. So Fibonacci of 6 will be the sum of 3 plus 5. This is 8 here. Now Fibonacci of 3 will be the sum of the previous two values. So 1 plus 1 equals 2. And so on and so on. Now, the Tribonacci sequence is pretty much the same, but it's the sum of the previous three values. So let's say Fibonacci of 6 is the sum of the previous three values, so 7, 4, and 2. That is equal to 13. For 4, the Tribonacci will be 1 plus 1, 2. 2 plus 2 equals 4, so Tribonacci of 4 equals 4. So this is pretty much what Tribonacci is. And if you've seen the solution for Fibonacci recursively, you're going to see something like this, right? We have all seen it before. When n is less than 2, we return n. So that's basically for 0 and 1, the values will be n. And now we return Fibonacci of n minus 2 plus Fibonacci of n minus 1. This works. However, the time complexity here is 2 to the n, which is very, very slow. So a common pattern we've seen for having a much faster solution is using memoization, which is kind of a way of caching. And basically, an object stores the previous results. So let me comment this out and go up here. And we have an object here, which is going to store all our previous calculations. So JavaScript doesn't have to compute the same values over and over. And this actually is going to run at O of n time. So what we do is have an if statement here and say, if n already exists in here, please return the value. But if it doesn't, we want to add that value to an object. So we say memo of n, let's say n is 4. We say Fibonacci of 4 minus 2 is 2, plus Fibonacci of 4 minus 1 is 3. So whatever this results here, we store it in memo, and then we return memo. And we can see the calculation here. We can do 7, that's 13, for 8 is 21. And that does match with the Fibonacci sequence. And it is run at a much faster rate than the previous solution without memoization. So if Fibonacci is the sum of the previous two values, we would say Tribonacci would be just adding Fibonacci of n minus 3 here, right? Yes, however, but we need to add something else, and we're going to see it in our next example here. And what we see is we did add only Tribonacci here of n minus 3. However, our base case does change because if Fibonacci summed these previous two values, Tribonacci needs to start with the previous three values so we don't get a undefined or something else. So we do have to start here with 0, 1, and 2 being in this object. So we just added this one compared to our last solution, and we added Tribonacci of n minus 3. So this is the way to do it recursively. It still runs at O of n time, and it is storing all these calculations on this object. So that is a way to resolve it if you've done it recursively before. Now, there's another solution that I want to go through, and is doing it with a for loop. So basically, we have a function here. Tribonacci is the same function. It receives a value of n. And remember, our base case for Tribonacci are the first three numbers of the sequence, right? So Fibonacci of 0, 0, 1, 1, 2, 1. So basically, this is our starting point. And if the value is any number less than 3, so one of these, it's going to return the position at which it is. So let's say Tribonacci of 2 will be at position 2, right? 0, 1, 2, and that returns Tribonacci. Now, what we need to do for larger numbers is have a for loop that starts at 3. Why at 3? Because that's the next number in the Fibonacci sequence. So let's say we wanted 3, right? We start at 3, and we're going to say the next number here in this array. Let me comment this, and we're going to say we have already 0, 1, and 1, right? So we're looking for the next number at position 3, which is this one, this I here. And first num's at I minus 3. Remember, this is pretty much the same we just saw up there. And we say 3 minus 3 equals 0 plus 3 minus 2 equals 1. 3 minus 1 equals 2. So it goes and looks at each position in this array. So it looks at 0 plus 1 plus 1, and that is equal to 2. And that will assign the value of first noms at that position, at position 3, to be equal to 2, right? And if n was 3, we would return and we would get that is 2, and we can validate it here. We got 2. Now if it's 4, it's gonna calculate first 3 here at position 3, and then it would say, okay, so I already have 3, and we're gonna sum 4 minus 3, it's 1, 4 minus 2 equals 2, and 4 minus 1 equals 2 here, right? And it would add 1 plus 1 plus 2, that would be 4, and it would store that value in this array, right? And we're done. It will return this, and we just validate it here with Tribonacci of 4 being 4. And you can look into Google Dev Chrome just to see what each step does. But I think this is pretty straightforward, and there's these 2 solutions that you can approach the problem with. Let me know if this clarifies it or if you have any extra questions, and I hope to see you soon.